The second thing I'd like to talk to you about today is a bit on unit conversion. And what I mean here is we're given amounts in different units of measure. If you're going to do the mathematics involving those units, you really have to get everything to kind of the same unit. And that is a crucial fundamental skill for someone who's really going to apply mathematics. You have to be able to do this. It's one of the first things you have to do. And it's just a little touch of algebra. It's really just fraction arithmetic. And I'd like to show you how to do that. I do want to say this about it. It does seem that this is something that's been taught in a fairly convoluted way. We teach you, if you're going from small units or big units to small units, you do one thing, and then if you go from small units to big units, you do the other. And I think that's kind of confusing. I think there's a better approach to this, and I'm going to show you a more uniform method for doing this, where you do the same thing every time. Okay, it's guaranteed to work. I call it unit cancellation. Some textbooks, particularly math, elementary ed for math teachers textbooks, will call this dimensional analysis, but that just sounds like something off Star Trek to me. It just makes it sound scary. I don't even want to call it that. So I'm just going to call it unit cancellation. And the trick is this: multiply by 1. That's it. Just multiply by 1. And then the one that we use depends on the conversion rates. Okay? We have to know the conversion rates. If we're going to convert from miles to feet or feet to miles, we have to know that 1 mile is 5,280 feet. Okay? But that gives me two ways to write 1. I can write 1 mile over 5,280 feet. Those are the same amount, so that's 1. Or I could reverse it. 5,280 feet over 1 mile, that's 1. And then what you do is you arrange the units you're trying to get rid of in the numerators and denominators opposite each other so that we can just cancel them out. Just treat them like a factor in the problem and just get rid of them. Okay, I'll give you an example. Let's say I want to convert 0.6 miles to feet. So I take my 0.6 miles, and actually I think of 0.6 as 6/10, so 6 in the numerator, 10 in the denominator, and then I put the unit in the numerator. And then I multiply by 1. And I do it in such a way that the mile unit and the mile unit here can be canceled. It's a slick little trick. And then I just multiply things out. You know, you can do some simplifying if you want to, but that works out to 3,168 feet. And yes, I did go from big to small, and I did multiply, but that takes care of it for me. Okay? It's kind of a nice little trick. I didn't have to remember, now which one do I do? Do I multiply? Do I divide? It takes care of it. Okay? Let me show you another example, and I'll go from little to big this time. Let's say I want to convert 40 inches to yards. Well, 40 inches, I'll put that in my numerator, and then I need to know the conversion between inches and yards, but I can go part of the way. I know that 12 inches is 1 foot, so I can get that canceled out. And then I just need to convert from feet, so I know that 3 feet is 1 yard. Cancel those out, and then I just work it out. 10/9, or if you prefer, 1 with a repeating 1/10. And yes, I did go from little to big, and yes, I did divide. But see, that system does not cover things like, well, what if your units are square units? Or what if their units are in the numerator and denominator? Okay, well, let's look at an example like that. Let's say I want to convert 2 square miles to square kilometers. Well, I put the 2 square miles in there. I have to look up, I don't know this one off the top of my head, I had to look it up, but 1 mile is equivalent roughly to 1.6093 kilometers. I can cancel the miles once, and then to cancel them a second time, think of this as squared, times itself, so I'll just multiply by it again, and then I can cancel, cancel, cancel. And in the end result, it gives me kilometers squared. I just have to work the problem out about a little over 5 square kilometers. Okay? Here's another one, and this is where it gets a little sticky. Say we're going to go from something like miles per hour to feet per second. Okay, now I not only in this case have to change miles to feet, but I have to change hours to second. Okay, again, multiply by 1. It's just this easy. Just arrange things so that you can cancel out the units. 1 mile per hour is 1 mile in the numerator and then hour in the denominator. I've already talked about how 1 mile is this many feet, and I arrange it so I can cancel the miles. Now let's get down to the hours. 1 hour is, okay, well, 60 minutes. Maybe you don't know how many hours or how many seconds are in an hour. So 1 hour is 60 minutes, and then you can convert 1 minute to 60 seconds. You're just multiplying by 1 each time. You're not changing the value when you multiply by 1. You get all of this done, do the arithmetic, it works out to 22/15 feet per second, or if you prefer decimals, that's almost 1.5 feet per second. Okay, the bar over the 6 indicates that that's a repeating 6. It goes on for forever. And in that case, you'll notice that I both multiplied and divided. You know, that's a situation where what they've taught in the past really doesn't help you out very much. Now, you may be saying, well, that's great, but how does that help me out, everyday stuff? I'm not going to be working serious math problems. Let me give you a situation where this kind of thing would be helpful. Let's say that you've just had your ride tricked out, you got a bigger set of tires on it now than you originally had, and you're concerned that even though your speedometer says 65 miles per hour, you're actually driving faster than that. You don't want to get any tickets because you're out of points or whatever, and so how can you check to see how fast you're actually going? Well, try this little test. Get on the interstate or parkway where you can safely drive 65 and not have to slow down, speed up. Set your cruise control to that speed. It can be actually any speed, but I'm worried about 65 because that's where I get tickets. And then it's important here that you go a constant rate of speed throughout this, and then drive between 2 consecutive mile markers. And then time yourself. Okay? See how many seconds it takes you to get from 1 mile marker to the next. So let's say it takes me 50 seconds to drive between 2 mile markers. Okay? Well, what I've done is I have driven 1 mile in 50 seconds. Let's convert that to miles per hour. The seconds I would convert to, I would do the conversion here. 1 hour, and I've already learned this, is 3,600 seconds. Okay? The seconds cancel out, and that works out to be 72 miles per hour. That's an indication if you were driving a constant 65 and you ended up with a 72, you're actually driving 72 miles per hour. You need to work on getting that speedometer adjusted, or at least just learn what is 65 miles per hour on your speedometer so that you don't get that ticket and mess up. I actually flashed up a few things here that might take a little time to digest. So again, I'm going to, as we kind of go to the last segment, I'm going to flash up a summary page that kind of summarizes everything that we've talked about up until this point.